tomorrow will be better. We have a ball of mass 0.5 kilograms rolling down a smooth inclined plane, inclined at 30 degrees to the horizontal, and we are told that it's released from rest. Now here is a question. Number one, find the acceleration down the plane, and to find the time it takes to reach B. Follow me, dear friends. Solution. The first thing is to pick out relevant information from this information. The first one here is release. Release here implies that the initial velocity u equals 0. Now smooth plane implies that there is no friction. Friction here is 0. Now find the acceleration down the plane. According to Newton's second law, F equals ma. This means that this acceleration we are looking for down the plane will be given by F divided by n. Now you're wondering, where will F come from? Besides, what is this F? This F in this context, dear friends, is what we call the resultant force. Now looking at it, there is no other force acting on this ball but for its weight, and this weight has to be decomposed. This is mg, has to be decomposed into a horizontal component and a perpendicular component with respect to the plane of action or of motion. So now experiment has proven it that this horizontal or this parallel component parallel to the motion of plane, to the plane of motion, is given by mg sine theta, where theta is this angle, while this other one here is mg cos theta. Now with this in mind, and in the absence of no other force, we will have it that this is the only force which is causing motion along this plane and in that direction. So F here is going to take the form of mg sine theta. So if we correctly apply this, this will mean that A, the acceleration down the plane, will be equal to mg sine theta all over m. The two m's will go off, and we know g 9.8 times sine of 30. If you correctly punch this on your calculators, you have that the acceleration down that plane will be 4.9 meters per second squared. Now, how to find the time it takes to reach B? Now that we have this important component, we will use one of the equations of uniformly accelerated motion, which combines this, the initial velocity, and the time which we are looking for. And it's none else but S equals ut plus half of at squared. We have to bear in mind that this component here will boil down to 0. Why? Because the initial velocity is 0. So what is this S here, dear friends? This is the distance